Coming to you from District. No, no, we're not coming from any districts. Welcome to another edition of Math. Today, we are not going to be doing anything with the Hunger Games. Do not be scared by all of this. You will all survive. It'll be good. We're going to take a look at solving equations with variables on two sides today. That's what we're going to be looking at. Also, the difference between one, none, and all solutions. And in the challenge section, you'll be learning about cliffhanger. You've got to wait. So let's get to it, shall we? So solving equations when there are variables on both sides. There's a lot of different ways that we could be going about this. I want to go over a few basic rules that I think work pretty well for kids. The first one is x's, variables, go on the left, and the second thing is constants, or those plain numbers, things that don't have variables attached to them, they go on the right-hand side. So I'll say constants go on the left. Go on the right, sorry. The other little tidbit I would be saying when talking about solving things and that sort of thing is that those two rules can flip-flop. If you really want the variables to go on the right, fine. Do constants have to go on the right all the time? No, they can go on the left. But the one thing you should always look for is your last step is usually dividing. So do realize that if you're dividing and then doing a bunch of other things, things are probably not going very well. So let's get to some examples, shall we? I'm going to give an example with an orange color today, I think. It's going to be exciting. First one, start off 4x plus 5. And that's going to be equal to x minus 4. Okay, so we've got variables on the left and on the right. We've got constants on the left and the right. So what are we going to go and do? We're going to go and get rid of the constant on the left by following the golden rule. So now we have 4x is equal to x. That's going to be minus 9. Now I need to get rid of that x on the right-hand side. So I'm going to subtract an x from both sides. Notice I've only done adding and subtracting so far. So that's all I've been doing. And that leaves me with 3x equals negative 9. My very last step, which I was just saying, is going to be to divide. I want to get that x all by itself, so I'm going to divide by 3. And my final answer is going to be x equals negative 3. So there you go. First example. Let's go into another one. Let's take a look at what happens if it's pretty complicated. So this is going to look a little bit intimidating right off the bat, but I think you guys can handle it and don't get scared. You shouldn't be scared of numbers. I've never had a number jump off a screen and eat you. There was one time, but that's okay. It happens once. Joking. There's no animals that jump off or numbers that jump off and eat you on the screen. So this one looks like, whoa, there's a lot of stuff going on. Let's go back to the idea of combining like terms. And also the idea that equations are split into two sides. When you combine like terms, you can only combine on one side. So over here, you see that you have y's and you have constants. So I'm going to combine all those on this side. Ignore, this side is like a completely different thing. So don't even worry about it. So over here, I'm going to combine my y's, and I'm going to also go and combine my constants. I love circling stuff with the sign to the left. I'm a big fan of that. So it says 7 minus 3. So it's nice and easy. You know exactly what's happening. So that leaves us with 4y. And then we have 5 plus 1, so 6. And this still equals 2y plus 2. Great. Let's get everything on the right side now, shall we? And by the right side, I mean the side that it should be on. So I'm going to subtract 6 here. I'm going to subtract 6 here. And that is going to leave me with 4y is equal to 2y minus 4. And now I'm going to go and get rid of that 2y by subtracting 2y, subtracting 2y, and that leaves me with 2y is equal to negative 4. I'm going to go and divide both sides by 2. So again, my last step was dividing. And my final answer is y equals negative 2. Awesome. Let's talk about the idea of solutions. So what did you actually just do? Well, negative 2 is a solution. It's a solution to this equation. So how many ways could I find a value for y that will make this true? Well, the only solution is negative 2. If I put in negative 2 into this equation, so I put it here, and I put it here, and I put it here, it would become true. If I magically went and did all of that, I would end up finding that negative 2 equals negative 2. So if I did all of that, this whole side, this entire side would become negative 2. And this side would become negative 2. So I would end up with negative 2 equals negative 2. So it's true. Yay. It's the only way to do it. One solution. So let's just try and get rid of some of this stuff then and talk about how many kinds of different solutions we can have. So we can have something called one solution, which you've just seen, and we can have something called all solutions. So all of these examples have been one solution. Let's see what happens when we do something and we get no solution. Take a look at this equation. P minus 4 is equal to negative 9 plus P. Okay. I'm going to go about solving as if I didn't know this was going to turn into no solution. So I'm going to add 4, just go along my merry way. Do. And P now equals negative 5 plus P. Cool. Now I'm going to go and get rid of this P. I'm going to subtract P from both sides. And what's P minus P? It's going to be 0. Nothing, right? It ends up completely gone. And I get this. So ask yourself, does 0 equal negative 5? Nope, it does not. That is false. So that is going to be the no solutions. You've already seen the one solution when there's literally one number. But what happens if there's all solutions? And what does all solutions really mean? Let's take a look. So all solutions is when any number you put in for x will work. That's pretty cool. I love these kinds of equations. So let's take a look at 8x. And this is going to be a long one. We're going to work on a lot of things. Plus 4 times 4x plus 3 is equal to 4 bracket 6x plus 4 minus 4. Okay, so you see this equation like, whoa, it's a beast. Let's get at it. first thing we're going to do, we're going to distribute, which means this positive 4 multiplies by both things, and this positive 4 multiplies by the 6x and by the positive 4. Everything else is just kind of left there. So let's go and distribute. So we're left with 8x still, plus 16x plus 12 is equal to 24x plus 16, and we still have that minus 4 that just kind of hangs out there. Let's go and combine our like terms. So I want to combine my x's on this side. I'm going to combine my constants on this side, and let's see what we get. We get 24x plus 12 is equal to 24x plus 12. Deja vu, did I just say that? So when you look at this, you'd be like, what is going on? And you'd look at it and you're like, whoa, look at that equation over there. And you're like, whoa, cool. You're like, wow, that's awesome. So if an equation is exactly the same on the left and exactly the same on the right, we call that all solutions. That means I could put any number in for x. 1, 82, negative 1,000, and it would equal the same thing. Sometimes you might actually go like, well, I want to go and keep doing this. So I go minus 12 because you want to solve it. So you're like minus 12, and you get 24x equals 24x. You're like, whoa, that's kind of cool. But my teacher said to get rid of the x's on the right-hand side. So you subtract 24x and you subtract 24x, and you end up getting 0 equals 0. And we call that all solutions. You will also see it referred to as infinite solutions. So there you go. So we've learned how to solve multi-step equations with variables on both sides, and we've also looked at one, all, or no solutions. Excellent job.
Great job on that section. Now on to challenge. Hopefully the odds will be in your favor. And we'll be looking at word problems involving distance, speed, and time. This won't be the first time we'll be talking about that kind of a word problem, but we're going to introduce it to you and see how that goes. All right, let's see how this works out.
So let's talk challenge, and we're going to be talking about questions involving distance, speed, and time. And in order to do these questions, we, of course, need to be using the magical triangle of distance. So let's go and draw it. So this is the triangle that will solve all of your distance, speed, and time questions. These are the classic questions that deal with trains going in opposite directions and the like that you've probably heard and seen, or you will hear and see. So the distance triangle has a D, an S, and a T. And this triangle will solve all those questions, and it even shows you how to. How does it do it? Well, here we go. If you wanted to solve for distance, that would be equal to speed times time. Well, look at the triangle. Distance is equal to speed. Now this is the cool part. Times, see the T there? For times, time. So it actually tells you how to do it. But say you wanted to solve for speed. Speed is equal to distance divided by time. Well, speed is equal to distance divided by time. It's right there. It's showing you how to solve everything. And lastly, time is equal to distance over speed. And there it is right there. Time is equal to distance divided by speed. So it's a pretty cool triangle. I highly recommend you look at it, love it, and internalize it, because you'll be using this for your whole math career. Let's get to a question now, shall we? So here we go. A passenger plane left Singapore and flew towards Moscow at an average speed of 485 kilometers per hour. A jet left 1 hour later and flew in the opposite direction with an average speed of 390 kilometers per hour. Find the number of hours the jet needs to fly before the planes are 5,735 kilometers apart. Okay. Classic question. Let's take a look at how we're going to tackle that. The very first thing is we need to go and draw Singapore. So here is what we'll call Singapore. So there's Singapore. And we're going in a jet, and apparently we are traveling in one direction, and we get to go to Russia. And there's another jet traveling in the complete opposite direction, like that. But there are some parameters. The first parameter, of course, is that it's going pretty fast. How fast is it going? It's going 485 kilometers per hour. How long is it flying for? Do you remember? Well, they never told us. It's actually going X hours. The other plane, though, the other one, is flying a little bit slower at 390 kilometers per hour, but it leaves 1 hour later. So think about it. If it leaves 1 hour later, and for flying time, if this is the total flying time, and this one leaves an hour later, this time would be x minus 1. We know that at some point, these two planes are 5,735 kilometers apart. That's what we know. But we want to know is how long does it take? So you're given the distance, aren't you? You are given the distance. So our equations are going to be looking like this. We're going to use the distance is equal to speed times time. Now, the tricky part for this part for kids to figure out is that it's not just this, is it? We're talking about the distance between two things. So we have two speed times times, don't we? We have this speed times time, and we have this speed times time. So really, this becomes distance equals speed times time plus speed times time. So, can we go and create our equation? Why, most certainly, we definitely can. And this is what it would end up looking like. 5,735 is equal to 390 times x minus 1, make that look a little better, plus 485 times x. I'm just going to put it like that. Okay, so now we have some basic distribution that we need to do, combining like terms and solving for x. So let's go and do that. I might need a little bit more room. So I'm going to go and just add some more space and maybe just start from scratch. So here we go. So here's the algebra. So 537.5 is equal to that 390 times x minus 1, which was the time, plus the original one, which is 485x. Let's go and expand our brackets. So 390x minus 390 plus the 485x. I'm going to go and combine our like terms. So I need to combine these two. And what do I end up getting? I end up getting, of course, 875x. So 875x minus 390 is, of course, equal to 5,735 still. I'm going to go and add the 390 by both sides. And that is going to go and give me 6,125 is equal to 875x. I'm going to divide both sides by 875. Divide this side by 875. And x equals 7. 7. But if we go back to the original equation and we take a look at this, I want to know how much time has to expire. If I put 7 back into here, which is the time, so x becomes 7, the time is actually 7 minus 1, which is 6 hours. And that is how long it will take. 6 hours. So there you go. The big things to kind of keep in mind is this distance triangle formula. It's really important. And applying this to different versions of the questions. You'll have different questions that ask about speed or time, and they'll give you different parts. But if you use these two formulas, or all three formulas, you'll hopefully be able to figure out what works for you.
See, I told you you'd survive. Hopefully you've enjoyed this lesson, you've learned a little bit about math. Send me a comment, leave it down below, and let me know. If you want a different kind of place for these videos, send me an email. Till next time.